Again, welcome to this guest talk by Ann Hess. She's going to be talking to us about writing about data analysis. And so let me introduce Ann and I'll have her take over. Ann is a professor, a CCA professor of statistics with the CSU Graybill Stats Lab. She has collaborative writing experience across a wide variety of disciplines, evidenced by joint publications and grants. So if you're thinking about not just writing, but then also thinking about collaboration and collaborative writing, she's got great experience there. Dr. Hess has taught applied statistics to more than 1,500 CSU graduate students from across the university, and she served on 50 graduate committees. So she's got a tremendous amount of experience in research and writing to share with us. So, Anne, I'm going to let you take over, and thank you so much for being here.
Thanks, Christina, and thanks for the people who have joined. I see my colleague Eric is here, and I see already a couple of students who are currently in the STAR courses. So the chat is live for this presentation, and there are going to be certain places after we go through examples that I'm actually going to stop screen share and open up the chat to get your comments on the examples. But if you have questions or comments as we're going through, chat or feel free. I think chat is good given the size. So the talk today is about writing about data analysis. And I've got it divided up just into a few sections. I'm going to do a brief intro to the Stat Lab for people who may not be familiar with us. And then I'm going to talk about planning for writing, the methods section, the results section, and if we have time, I'm going to cover a few common reviewer comments that I see emerge as themes. So first, the Stat Lab. The Stat Lab mission is to provide statistical expertise for the benefit of advancing the quality of scientific research at CSU and beyond, while educating the next generation of applied statisticians. And there are two of us in the Stat Lab, myself and Dr. Eric Galeland, who is on the call today as well. So the primary way that we offer support through the Stat Lab is two different venues. We offer appointments with faculty consultants, so that's Dr. Galeland and myself. And we encourage people to use that option for support relating to research proposals, study design, more complicated statistical analyses, manuscript preparation, and reviewer comments. And for today's discussion, I kind of highlighted or italicized, I guess, that, we do offer support with writing. So obviously a proposal is a written document, manuscript preparation, and reviewer comments. Let me see the chat. Oh, that's just... And then the drop-in lab is staffed by stat grad students, no appointment necessary, and they offer guidance with data formatting, data wrangling, data visualization, and maybe common statistical analyses. And you can't go wrong. If you visit the drop-in lab and it's a more complicated question, they'll just encourage you to schedule an appointment. For CSU users, there's no charge for general consulting for most projects. And this service is supported by the Ag Experiment Station, the College of Natural Sciences, and the Statistics Department. We do request funding for grant-funded projects, and fee-for-service data analysis is available for projects that go beyond general consulting. But most of what we do in the Stat Lab, there's no charge. There's never a charge to schedule a meeting. So now going into today's topic, again, I'm going to divide it up into three sections, and the first is planning for writing. So these steps can and probably should be taken before you start the analysis. And I'm going to divide it up into writing an analysis plan, check the journal requirements, and look in the literature. So as the name implies, an analysis plan is a plan for analysis and presentation of results. So this can be pretty informal. I think many people just make an informal analysis plan that's really just for their own internal use, and that's kind of how I think of it. But the benefits include making and justifying analysis choices up front. This provides some accountability such that we can avoid selective reporting of results if we kind of decide up front what we're going to do and what we're going to present. If done well, the analysis plan is the start of the methods section. So if you go through the process of making this analysis plan, it's okay if things change in your plan, in most cases, but either way, it can be the start of the manuscript. I think a big benefit for grad students is that this is an opportunity for your advisor and committee to provide comments and suggestions in advance of running the analysis. And I think that there can be a lot of benefit to getting, the people who are close to the project to sit down and think through the analysis in advance before we start that. One thing that I encourage people, whether or not they have an analysis plan, is to potentially identify a small number of primary response variables. So it's pretty common, and in the examples we'll look at today, we'll see that the studies included multiple response variables, or another name for response variables is dependent or outcome variables. And if this applies to you, it can be helpful to identify a small number as primary before starting the analysis. So the primary response variables are the most important variables based on your research question, regardless of the later results. And if you can do this, you might also consider defining a meaningful effect size for these primary responses. I'll come back and define effect size later in this talk. And one of the examples, we will see how they used a primary response variable versus secondary. I don't see many people do this, but I want to put in a plug for pre-registration, which is really the idea of an analysis plan, but making it a formal public document. So pre-registration is the practice of registering the hypotheses, methods, or analyses of a scientific study before it is conducted. Some journals have specific processes for this. I don't think any journal requires it, but some allow it as an option. And for those journals, the protocol is peer-reviewed, and then the publication of the resulting report is guaranteed. There are also open registries. So it's my experience that even when people do this, it's more likely that they're using an open registry rather than a journal-specific process. We'll see one example today where somebody pre-registered. I also encourage people to check the journal requirements. So different journals will have different author guidelines and requirements. And some journals provide specific details regarding analysis and presentation of results. So as an example of that, this excerpt, really this is just a subset of a much longer document, but this is from the journal Ecology, which is published by Wiley. And in their author instructions, they have a link to these ESA guidelines for statistical analysis. So for reporting of analyses, part of what they say is the specific statistical procedure must always be described in plain language or using equations, i.e., just referring to a function within a specific statistical program is not sufficient, with the goal that a knowledgeable reader could reproduce the results when provided with the raw data. In addition, key components of the computing environment should be cited and version numbers should be included. And they specifically request that R packages should be cited. So there's checking the journal guidelines, but another step is to just look at examples of other published papers in the literature. So it's my experience that standards and conventions vary by discipline and even by journal. And a literature review is part of most research projects anyway. So often it's just a matter of taking a look at how those papers in your literature review may have presented their results and even what statistical methods they may have used. For grad students especially, I think it can be very helpful to see how others have analyzed and presented results from similar studies. And we don't have to do the same things that those other people did, but I think it gives you an idea in your target journal what it looks like to write up a statistical analysis and report those results. So I don't have any examples specifically of planning. So now I'm going to move to a few tips for the methods section. And at the end of this, we will get into 2 or even 3 extended examples. So the topics are software. A motto that I like to use is make it easy for the reader. So you've done all the hard work of conducting this study, doing the analysis. Now we want to make it very easy for the reader to follow what was done. Be transparent and grouping and ordering. So it is very common for papers to state what statistical software and version was used. So this is easy to do. For R, it's also appropriate to cite key packages that were used for analysis. You don't necessarily have to cite every single package that you used in your R session, but I think of referencing the key ones. For R packages, you can find the author's preferred citation by using the R code citation and then the package name in quotes. So that will give you, if that package author published a paper and that's what they want you to reference, it'll show up this way. Remember that the R package authors work for free. So citing their work is a way to give them credit. This costs you nothing and is can be helpful to the package author in addition to often being helpful just in general for writing up your results. Next, make it easy for the reader. And I'm going to go back to something that appeared in those ecology guidelines because I think this is the overarching idea. We want to provide enough information with the goal that a knowledgeable reader could reproduce the results when provided with the raw data. A really easy thing to do is to clearly specify the response variable. So that might also be called a dependent or an outcome variable, and the predictor variables for each model. Again, this is probably obvious to you as somebody who's spent a lot of time working on the analysis, but these kind of breadcrumbs are really, really helpful for somebody who's trying to learn about your project. We want to briefly explain what was done, and where reasonable, we want to maybe give a brief suggestion of why you did what you did in the analysis. And I'll have some examples of that. Use plain language. Don't expect the reader to know a specific software program. So try to describe what you did with as little statistical lingo or R lingo as possible. Try to make it easy for somebody to read, even if they have less experience than you. Next up is the idea of be transparent. And for this, I'm taking just a very brief section from the American Statistical Association Ethical Guidelines for Statistical Practice. And they have a bunch of principles. I'm zeroing in on principle B, integrity of data and methods. So the ethical statistical practitioner is transparent about assumptions made in the execution and interpretation of statistical practices. They convey results or applications of statistical practices in ways that are honest and meaningful. They are transparent regarding a priori versus post hoc objectives and planned versus unplanned statistical practices. They disclose when multiple comparisons are conducted and any relative adjustments. Again, this is just a tiny subset of a much larger document. But I like here that this idea of transparency and honesty and disclosing comes up many times in these few bullets. The next one has nothing to do with statistics and probably a lot to do with the human mind and just reading. So the idea of just grouping and ordering your analysis and your results. So often studies have multiple response variables, and we're going to see that in all of the examples in this talk. If possible, group the response variables by analysis or by model. So we'll see specific examples of this, but even if you have 10 response variables, it may be for 7 of them you used one analysis, and for 3 you used a different analysis. Then simply grouping those and describing the analysis in that grouped fashion is really helpful for the reader to follow along. In many results, these groupings can extend to the results table. And to the extent possible, use the same variable ordering throughout the paper. So again, this has nothing to do with statistics. It's just a simple organizational strategy that's going to allow someone new to the project to follow and absorb the information more quickly. And so that might even be presenting the variables in the same order in the title, in the methods, and in the results section. And again, it's not always possible, but I think these simple strategies are really, really helpful. So now we're going to do our first example paper. And one of the challenging things about finding examples here is I needed to choose things that are reasonably complex, such that there's kind of an interesting methods section to talk about. But statistics always requires context. So in order to make any sense of what they did in the analysis section, I really have to have about a whole slide introducing the study. So this first one I'm going to call the acupuncture example. And this was, some of the authors are from CSU on this study, specifically from the Clinical Sciences Department, which is part of the College of Vet Med here at CSU. And I have the full citations for these articles at the end of the talk, but I'll just call this the acupuncture example. So the title is Evaluation of Acupuncture for the Treatment of Pain Associated with Naturally Occurring Osteoarthritis in Dogs. So just like the name implies, they've pet dogs, typically older, who were experiencing osteoarthritis, and they were investigating the effectiveness of acupuncture. They do actually do acupuncture treatments for dogs at the CSU Vet Hospital. The aim of this study was to prospectively evaluate the efficacy of acupuncture on lameness and clinical function in dogs affected by naturally occurring OA. A total of 32 client-owned dogs completed this prospective, randomized, placebo-controlled, blinded clinical trial using a crossover design. So what was meant by a crossover design? The participants were assigned to receive placebo or acupuncture treatment once weekly for 4 weeks in a random order with a 2-week washout period. So each of the 32 dogs got both the placebo and the acupuncture treatments in a randomized order. That's what's meant by the crossover. So they chose percent BWD, body weight distribution, as their primary response variable. And they did that because it has been suggested to be the most accurate gait parameter. So they were able to do that up front before starting the analysis. So now we're going to get into their excerpt from their methods section, focusing on statistical analysis. And I tried to be as true to the published article as possible, although I definitely tried to be succinct. So analysis was performed using SAS software, version 9.4. Residual diagnostic plots were used to evaluate model assumptions of normality and equal variance. They give us a long list of response variables. I'm not going to read these out because there's a lot of abbreviations, but basically the first line and a half here are all response variables. So each of these response variables were analyzed using a mixed model that was fit separately for each response variable. Visit, baseline, post-acupuncture, or post-placebo was included as a fixed effect in the model. Each individual dog was included as a random effect to account for repeated measures. Tukey-adjusted pairwise comparisons were used to compare between visits. With the exception of the primary outcome, Bonferroni adjusted F-tests were used to account for multiple testing for the other variables. The Wilcoxon signed rank test was used to evaluate treatment efficacy questionnaire, since this data was not normally distributed. Okay, so this is the first one, and feel free if you want to go into chat and mention something that you think of as a strength of that analysis description. And if you see a weakness, you are welcome to say that too. So I'm going to stop screen share so that I can see the chat. I'm going to give people a chance to think for a moment. But any strengths or weaknesses? I'm not good at being quiet, but I have to be quiet and let people have a chance.
And I wonder if would you mind actually showing the list again? That actually might help folks to be able to identify, so they could just pop in. Does that make sense? That might
Yep.
be helpful. I know it's lovely to see you, and you can chat with people, but but yeah, like there we go. Yep, seeing what some of those are.
Maybe I'll do it as a kind of a leading question.
There we go. And Lauren's jumped in.
I'm going to leave this. I think, can I do it? Yeah, I can do that and I can still see the chat. Okay. The software and version were specifically named. Yep. But not those packages for each of those tests that they did. That is true. So they just said SAS version 9.4. In SAS, they have procedures, procs, they say. Anybody else want to see something, mention something that was a pro or a con? And thanks to Lauren for using the plus. That's why I put the plus and the minus on the slide to kind of make it easy to identify benefit or limitation. They grouped and ordered the response variables. Yes. Strength is the efficiency of conducting in just certain sample size, but double observations. Yes, so that's a strength of the design, Yaling. I totally agree. I want to go back to what Maggie said about grouping and ordering the response variables. It was a really long list of response variables, but I liked that because it told a reader very clearly that all of those things were used as response variables. And again, that's one way to ward off selective reporting or losing somebody. And maybe we didn't know that they ran that mixed model for, in this case, I think it was about 15 response variables. Anything else that people want to mention? Okay, and that's okay too. So I'm going to, I've got a little cheat sheet next to me, and I'm going to talk about it. One thing, and I used some highlighting here to help remind me, I'm sorry, italics, I guess. But does everyone see in italics, what they did was provide a why, a very brief explanation for why they did something. So dog was included as a random effect to account for repeated measures. Tukey adjusted pairwise comparisons were used to compare between the visits. The Wilcoxon test was used for one or two of the response variables because that data was not normally distributed. And it didn't take much space, but it kind of proactively told a reader or a reviewer why they did something. Okay. The other nice thing, and one reason that I chose this article was this was a place where they really did have a primary response variable. And basically, they used that, they took that into account for multiple testing reasons. And I might have time, we might see this example again. Okay. I guess one more that I have on my list, and this will make it easier for the next one, was they talk about checking the model assumptions. So the first, basically the second line is residual diagnostic plots were used to evaluate the model assumptions. Should use present tense. Eric, that's a good point, and I'm terrible at knowing what verb tense to use. I think typically as long as they're consistent within the article, I think it's okay, but good point, Eric. Okay, I'm going to close chat again for right now, but you're going to have another pass at this because we're going to go right into the next example. Okay. All right. So the next example, the short way I'm going to refer to this is the cattle example. But this was the authors of this paper are from CSU Animal Sciences, which is part of the College of Ag Sciences. The title is Pre-Slaughter Factors Affecting Mobility, Blood Parameters, Bruising, and Muscle pH of Finished Beef Cattle in the U.S. So this study aimed to track individual animals throughout the slaughter process to identify pre-slaughter factors that are associated with key welfare and quality outcomes. So This topic might be a little sensitive to people to think about the slaughter process, but a big motivating reason that they did this study was to focus on animal welfare, to think about what things are associated with better animal welfare, even during the slaughter process, because that is part of the lifespan of a production animal. A total of 454 cattle from one commercial slaughter facility were studied. Pre-slaughter factors assessed included distance traveled, truck waiting time, lairage density. I'm going to let the rest go off. Then we move into the statistical analysis. So all statistical analyses were performed using R, they give us the version, with individual animals serving as the observational unit. Descriptive statistics were calculated for all variables of interest. Continuous variables were summarized for their min, mean, max, and standard deviation, and categorical variables by their relative frequency. For analysis purposes only, some variables were collapsed into smaller categories. Due to low frequency of mobility scores 3 and 4 observed, mobility was categorized as binary. Mixed model analysis was used to account for lot effects, as there were multiple animals per slaughter lot. Continuous response variables, and again, they give us a list, cortisol, CK, lactate, and muscle pH, were analyzed using linear mixed effects models. They're giving us an R package, 2 R packages. Diagnostic plots were used to assess model fit and ANOVA assumptions. To account for non-normality, a log transformation was performed on CK data for analysis. Mobility, a binary response variable, was analyzed using a mixed effect binary logistic regression. Type 3F tests were used. Pairwise comparisons were calculated using the EM means package. Statistical significance was determined at p less than 0.05. AIC was used to evaluate regression models with multiple predictors. And then basically in this next bullet point, they're listing out all the predictor variables that they considered during the model selection process. But they're also letting us know that when they were modeling using mobility and pH as response variables, they included lactate as an additional predictor. So they're telling us all of the predictor variables that they considered and breaking it down by different responses. Okay, so hopefully this one feels easier, but would people like to take a stab at benefits, positives and negatives about the write-up? And some of them overlap. And I've got, I guess where I always struggle is trying to see the chat while I'm screen sharing, but I will go back to screen share. I think maybe I kind of like going to this list where I talked about just kind of what things we might look for. See, now I can't see the chat. There it is. There's my chat. Davida, group the statistical test with the variable that each test looks at, right? So they had some continuous response variables and at least one binary response variable, and they separated those and talked about the analysis method separately. Lauren, they did less explaining of why did we do these tests in this one. I agree, there's less of that. Not sure which their primary outcome variable was. Yep. And sometimes people don't have a primary outcome variable. I would say it's actually less common that people specify a primary outcome. But that's something I liked about the first one. Maybe too many predictor variables that pose difficulty to isolate the cause. Fair. But this idea of having multiple predictor variables and doing model selection is also really common. But what I like is that they told us exactly what predictor variables they included in each model, which ones they were considering, because there were a lot of predictor variables. Any last ones that people want to talk about? Okay, I'm going to go back to the slide. Okay, so very explicit about exactly what they did. Yep. But I found the ordering to perhaps be confusing. Yep. And I think it's hard. It was hard for me to find articles because they needed to be complex enough that they're interesting to talk about. But the trade-off is it's going to be hard for people to absorb quickly in just having 5 minutes. So I'm just checking my cheat sheet. And I've talked about some of these already. So obviously they got the software. So they mention R. And this time they have R packages, and even the version numbers are specified. They checked assumptions. So here they say diagnostic plots were used to assess model fit and ANOVA assumptions. I really found it helpful how they grouped the variables. So they started with the continuous variables. They listed out which those were. Then they talked about that analysis. Then they moved on and talked about the binary response variable with the understanding that that requires a different analysis. I think they have some why, some justification, and I tried to italicize that. So to account for non-normality, they used a log transformation. To account for lot effects, they used a mixed model. Okay, so to me, they did some of it. Okay, I'm just checking my list. And I already said that I know they have a lot of predictor variables and that's hard to take in, but they listed them all out. And so I could tell, for the purposes of model selection with AIC, what predictors they considered. Okay, so now we have one more example in this group, but I think I'm actually just going to do a tiny bit on this example, which makes me a little sad because it's another interesting CSU study, but I want to make sure I have time for the other sections. So I'm going to shrink the chat. So the VR, standing for virtual reality example, is from Amanda Spitzer, is a graduate student in the psychology department here, which is part of College of Natural Sciences. So I want to call out that I've used examples from 3 departments, but also 3 colleges. And the title is VR versus IRL walking. Equivalencies and discrepancies between walking through a downtown district in virtual reality and in real life. So VR is virtual reality and IRL is in real life. So for virtual reality to be employed in walkability research, the degree to which walking in VR mimics the real world must be quantified. In a pre-registered study, 39 participants walked in a historic real-world district and in a VR replica. In both environments, participants completed errands by either walking to specific locations, like a bank, or choosing alternate transportation option representing driving. So I think I'm going to skip this one for time. But the first thing, and the reason I wanted to call this one out, first of all, it's a human study. The other 2 are animal studies, and I wanted to make sure I got something different. But this was a pre-registered study. And the way that was used, you can see it at the beginning of this analysis section. The analyses for each dependent or response variable were pre-registered as one of 3 different approaches, depending on the type of data and the research questions. So another thing that we won't go into is, again, this idea of grouping those response variables with the additional example here that Amanda actually pre-registered this project. Okay, so unfortunately, I'm going to skip the rest. So next up is the results section. So the 4 points I'm going to hit before going back to some examples are sample size, descriptive statistics and effect sizes, p-values, statistical significance, and evidence. And then we'll go back to one example that we've already seen, plus an additional new example that I'll introduce. So the sample size should be clearly stated. I feel really strongly about this. I actually didn't know where to put this in today's talk, so I went with results. But in practice, the sample size might appear multiple places, and that's not bad. So it might appear in the abstract. I think we've seen that already in all 3 of the examples. It might appear in the methods section. It might appear in the tables that typically appear in the results section. There are many times when the sample size actually gets complicated. So examples are when there's imbalance or missing values, and maybe missing values only for some response variables, crossover designs, nesting. In those cases where it's harder to talk about the sample size, that just makes it more important to clarify the sample size throughout the article, okay? Next up is descriptive statistics and effect sizes. So when discussing results, the focus should be on the estimated values or estimated differences. A formal way to call that is effect size. This gives the reader information to judge whether the results are meaningful or practically important. This is not difficult. Presenting and emphasizing model estimates and/or descriptive statistics address this. Along with these, we want to give information about variability. So that might be the standard error or a confidence interval. So I already gave some examples of effect sizes. I find that the term effect sizes confuses people. And so I wanted to give some specific examples of what effect sizes are. And I think when I do this, most of these should feel familiar to people. But for some reason, the generic label effect size kind of scares people or confuses people sometimes. So it's increasingly common for journals to request effect sizes. And it's my belief that most people are already doing this. But maybe you just hadn't thought of that as an effect size. So for the very common situation where we're comparing means, the basic or unstandardized effect size is just the estimated difference between the means. So it's just the difference between the sample means. Okay, and that would almost always be presented in some summary statistics. A related idea is Cohen's d is an example of a standardized effect size. So that's just that same difference, estimated difference between the means divided by a standard deviation. But let's think of other examples. So for a linear regression setting, maybe a multiple regression, the estimated coefficient or slope is the effect size. For a logistic regression setting, the odds ratio is the effect size. And my point here is effect size is just a generic catch-all, but most of the time I think people are familiar and are already presenting this kind of output. And it is totally fine to say in your methods section, the odds ratio is our measure of effect size, for example. Next up, p-values and statistical significance. So in 2019, there was an editorial published called Moving to a World Beyond P less than 0.05. This editorial has been cited thousands of times. And one of the big recommendations that those authors made was they recommend not using the term statistically significant. Okay? I want to be very clear. It is okay to calculate and present p-values. They are not saying to not use p-values. Their primary issue is with the term statistically significant and perhaps the interpretation of p-values. So we want to avoid dichotomizing p-values. I recommend that you present the actual numeric value, not just p less than 0.05, p greater than 0.05. Another, again, very brief excerpt from that is for the integrity of scientific publishing and research dissemination, therefore, whether a p-value passes any arbitrary threshold should not be considered at all when deciding which results to present or highlight. And my Star 511 students, we actually, just the way the class worked, you all saw this material today. And one thing I didn't say in class today, but I'm going to say now, is because their article is focused on p-values, they say whether a p-value passes any arbitrary threshold, blah, blah, blah. But I'd like to call out that I could fill this in with other values. Whether a confidence interval passes any arbitrary threshold, whether an AIC value passes any arbitrary threshold, whether a Bayes factor passes any arbitrary threshold should not be considered in deciding which results to present or highlight. Okay, so I'm not going to ask people to use chat just because of time, but the question then becomes, how do we decide which results to present or highlight? And my answer to you is, the answers to the most important research questions. And I don't need a p-value to tell me what was the most important research question. So personally, I have moved to phrasing results in terms of statistical evidence. So when I find a p-value less than 0.05, we find statistical evidence of an association or difference. For p greater than 0.05, we do not find sufficient statistical evidence of an association or difference. So you could argue we're still dichotomizing, but I do like the term statistical evidence over statistical significance. And in the reference is at the end. This is an ecology paper, but they published an article called Rewriting Results Sections in the Language of Evidence. And they basically are saying the same thing. Instead of statistical significance, use this language of evidence. Okay, so now we're back to the acupuncture example, okay? And they had a whole written results section, but I'm going to go to just a subset of a table of results. And so here you can see 4 different response variables, BWD, PVF, and 2 more. Let me just orient you a little. Then remember that for this study, they had 3 visits. So they had the baseline visit, and then they had the acupuncture and placebo visits. So this table is arranged, it's kind of a unique format here, but here they have the mean and the standard error for baseline for BWD. Then they have the mean and the standard error still for BWD for acupuncture and placebo. In the next 2 columns, they have p-values for the different pairwise comparisons. So here's a Tukey adjusted p-value for baseline versus acupuncture, and a p-value for baseline versus placebo, and the third Tukey adjusted p-value for treatment versus placebo. Okay? And then down in the footnotes, and I made this bigger so that we could see it, they say asterisk, so they have the exact p-value and then they have an asterisk, and it says indicates evidence of a difference based on p less than 0.05. So this was an example of a paper where they did not use the phrase statistical significance, but they did talk about things in terms of evidence. Okay, so I still think, even though we're moving, we're getting to 1:45, I still think I'd like for people to maybe just mention one strength or weakness of the results presentation. And maybe I'll keep it on the tape. Exact p-values. Yep. So they still use the asterisk notation, but they also had the numeric p-value written out, not just p less than 0.05. Anyone have another one? They explain which variables have adjusted and unadjusted p-values. Yep. And that was a unique feature of this one where they did, and this is how they used that primary response variable, because they applied a Bonferroni adjustment to all of the other variables, but they didn't do a Bonferroni adjustment for the primary response. They kind of got that one free because it was their primary response variable. But they explained that within the context of the table. Okay. For time purposes, I'm going to say the other one is, that they did effect size in a very easy way. They give us the means for all 3 of the visits in a very simple format so that we can judge for ourselves the magnitude of those differences. So it's not quite an effect size, but they gave us all the information we needed to calculate an effect size. Okay. So with that, let me shrink chat again, and I'm going to try to squeeze in one more example. But unfortunately, that means introducing another example. So I'm going to try to do this quickly. So this is not a CSU paper. I'm going to call it the cat bites example. So the title, Animal Trauma Triage Score, and things that were associated with outcome in feline bite wounds, N equals 1,065 cases. So their goal was to identify associations between admissions variables, all these various predictor variables, with survival to discharge in cats with bite wounds. So all 1,065 cats in this observational study had experienced a bite and had been brought to a vet hospital. Could have been CSU Vet Hospital or another member of this group. So the animals are 1,065 cats with bite wounds. Okay, then they're telling us more. I don't think we need this for what we're going to do. Okay, so what they did in this and what's presented in this table is they did a whole bunch of univariate logistic regressions. So for survival, they looked at the association between age and survival, weight and survival, sex and survival, and all of these other things. Okay, so in this case, for this table, they have one response variable, which is survival, but they had a whole bunch of potential predictor variables. And I'm going to tell you the reason I picked this study, even though it meant introducing a fourth study, is this one column right here, the number. So because this is an observational study, they have the age for most of the cats, but for some of the other predictor variables, like the blood variables over here, they only had, say, lactate measured for 264 cats. And I just really like in this table that it's very easy for a reader to see that that sample size varied, okay? Another really easy thing that I kind of liked and made this one stand out to me was, I'm not going to go into the details, but odds ratios are sometimes tricky for people to interpret. And they actually gave us some like little breadcrumbs right in the table caption. So they say odds ratio greater than 1 indicates that the variable increased the odds of dying in hospital and not being discharged, whereas OR less than 1 indicates that the variable decreased the odds of dying in the hospital and not being discharged. Maybe they get a little too close to causality in that verbal statement, but I like this breadcrumb about what odds ratio is giving us. And I guess the last thing is odds ratio is their effect size, but they also give the p-value and the 95% confidence interval for that. Okay, so I won't ask for feedback on that one, but I just liked it. I really like how it's so easy for me to see that the sample size, the effective sample size varied for these different predictor variables. Okay, so we're at 150. So what I'm going to do is I'm just going to, actually, I think I'll do this one slide in the frequent reviewer comments, because the number one most frequent reviewer comment, people often think that the reviewer is saying that their analysis was wrong or not appropriate. And of course, that is possible, that they're going to have concerns if they feel an analysis was not appropriate. But I actually see so many people visit in the stat lab. When I look at the reviewer comment, what I see from the reviewer comment is that the reviewer just didn't understand what was done. So I would ask you, when you read your own results section, could someone else recreate your analysis? Have you told them what is the response? What are the predictors? What method was used? And the other one is occasionally a reviewer wants more information about why certain methods were used. And I find, and I tried to do some examples of this, that just really brief breadcrumbs can help proactively justify the choices. So like, for example, we saw reference to a mixed model to account for repeated measures, or Tukey adjustment to control for multiple testing. And it can be really, really brief. But those little breadcrumbs I often think are really helpful and prevent reviewer comments. So I want to be respectful of people's time. So I'm just going to I'm just going to say another one is checking assumptions, and then the final one is multiple testing. But with that, I saw Christina try to come on, and then I said one more thing. I tend to do that, Christina. I want to thank everybody for attending, but if people have questions or comments, I'm happy to hear them at this point.
And can I just say that was amazing? Thank you so much. This is so helpful. And I love that kind of finality of when you get reviewer feedback, like oftentimes just a lack of understanding of on the page. It's not that there was anything wrong with your study. It's not right or your data. It's just, yeah, how it is that you've worked with it.
Yeah.
Yeah. So you got some questions in the chat for those who can stick around and have some questions for Anne, please do so. And then for those of you who cannot stick around, if you have another obligation, just know that CSU Rights will reach out. We'll do a follow-up. We'll share out the recording and you can have access to it and information from Anne. And please just give us a little bit of feedback. All right, everybody. Thanks so much. And stick around if you have questions.